I'd like to talk about finding vertical, horizontal, and oblique asymptotes. So first we'll talk about vertical asymptotes. Vertical asymptotes actually are, out of the three, these are the easiest to find, and they're also among the most important. So vertical asymptotes are going to occur where the denominator of a rational function in lowest terms equals 0. I'll give you an example of one that's not in lowest terms in just a minute. So let's do a few examples. And you're welcome to try these and pause it based on my definition above. So for number 1, we are going to set our denominator equal to 0. We get x plus 4 equals 0. That gives us x equals negative 4. That's our vertical asymptote. That's all you need to do for that one. 2 is the same idea. You can either factor this or you can solve it using square roots. If you do using square roots, don't forget that there is a plus or minus. So I have a vertical asymptote at x equals positive 2 and a vertical asymptote at x equals negative 2. For number 3, if you set your denominator equal to 0, you're going to find that the answer is positive or negative I. Actually, we can't have imaginary vertical asymptotes. So in this case, we don't have any vertical asymptotes. For number 4, I want you to notice that this one may or may not be in lowest terms. So we actually need to factor this one out first. So I'm going to factor it, and then I'm going to see if anything cancels. If something cancels, that means that it wasn't in lowest terms before, and we do have to actually get that. So when I factor everything, this is what I get. You'll notice that the x minus 3's cancel. So if you remember from the previous video, x equals 3 is not in the domain. However, it has another, we're going to be using that for something else in a later video. These two things cancel, so actually in lowest terms, this is my function. So my vertical asymptote is going to occur when x plus 7 equals 0 or x equals negative 7. And I think I mentioned this before, but I think it's important that I mention it again. Don't forget to put the x equals. It is a line, so it's important that you write it as an equation of a line. So horizontal asymptotes are a little bit more involved, not because it's really hard math, but just because there's a bunch of rules going on. So I'll give you the rules. You probably will want to write them in your notes because you will be using this a bunch of times. So for this general equation, we are going to have 3 rules. And I'm going to tell you right now, if this equation if you're just looking at this and you're super, super confused, I think probably once we go over a few examples, it'll clarify a bunch of things. But for now, the only thing I really want you to notice is that the degree of the numerator is n and the degree of the denominator is m. So if for now you just want to notice that this is a comma, by the way, not in 1. If you just want to remember that, you should be fine. So first rule is if the degree of the numerator is less than the degree of the denominator, y equals 0 is a horizontal asymptote. So for example, if you have like y equals x over x squared plus 2, that one has a horizontal asymptote at 0. So our second case is if the degree of the numerator and the degree of the denominator are equal, the horizontal asymptote is going to be at the leading coefficient of the numerator over the leading coefficient of the denominator. So if you're a little confused on that, I think it'll be easier once I give you an example. So let's say I have like y equals negative 5x squared plus 8x minus 2 over 3x squared plus 9x minus 3. For this one, all I need to do to figure out my horizontal asymptote is look at my 2 leading coefficients. I have this negative 5 and the 3. So that one has a horizontal asymptote at y equals -5/3. So then the third situation is if the degree of the numerator is bigger than the degree of the denominator, there is no horizontal asymptote. However, if you have the degree of the numerator being 1 more than the denominator, I'm going to say that would be n equals n plus 1, there will be an oblique asymptote. So I'll give you an example, just so you can kind of see what's happening there. So, for example, if you have f of x is equal to x to the 4th minus 3x over x cubed plus 8x, this one has an oblique asymptote, but no horizontal asymptote. By the way, my abbreviation here, OA, is oblique asymptote. However, if instead it was like f of x equals x to the 4th minus 3x over x squared minus 8x, that one would have no horizontal asymptote, and it also has no oblique asymptote. So the horizontal and the vertical are by far the most important. We will do one example with the oblique asymptote. You'll probably just have one question on your quiz about that. So I think that one is the harder one out of the two. However, the horizontal, there are a bunch of rules. So just keep that in mind that you do need to know these rules. And all of the rules that you have actually are going to come up again next year in the first few weeks of calculus. So you will be seeing them again. So actually, before we go on to oblique, let's try a few examples. I'd actually like you to pause and try these. So for number 1, you'll notice that the degree of the numerator is equal to 2. The degree of the denominator is equal to 4. Since the numerator degree is less than the denominator degree, I just have a horizontal asymptote at y equals 0. Number 2, I have the same degree for both the numerator and the denominator. That's the one where I look at the leading coefficients. So I'm going to look at my, my leading terms, and I do end up getting 3 over 6, which simplifies down to 1/2. So then for number 3, my numerator has a degree of 3, my denominator has a degree of 2. The numerator degree is greater than the denominator degree by 1. What that means is that there's no horizontal asymptote. However, there is an oblique asymptote. So, and we're actually going to find that one in just a few minutes. For number 4, this one, the numerator degree is greater than the denominator. It's actually greater by 2. So this one, there's no horizontal asymptote, and there's also no oblique asymptote. By the way, if you have a situation like 3, you do not need to find the oblique asymptote unless you are specifically asked. You can just say that there's no horizontal asymptote if that's what you're being asked. So we're going to do an example of oblique asymptotes. These are going to occur at the quotient of the numerator divided by the denominator. By the way, you do not need to worry about the remainder. You're only going to be looking at the quotient portion of it. So let's go ahead and do an example. So this is the one that I gave you in the previous thing with the horizontal asymptotes. And the way that we're going to find this is by polynomial long division. Not a pleasant one to do. Unfortunately, you cannot use synthetic division on this one. You might be able to try to factor it, but I don't think that's really going to help you very much. So we're kind of stuck using polynomial long division. You're welcome to pause the video and try this on your own if you'd like. So, but I'm going to work this out. So we are going to start with 2x cubed divided by x squared. That is going to give us a 2x. And then if I multiply that back, I get 2x cubed plus 6x plus 6x squared. Then I subtract, and when I subtract, I end up, change my color, I end up making everything down here negative. The two x cubes cancel out, I end up with negative 6x squared minus 12x. I bring down my plus 1, and then I repeat the process. So now I'm going to do negative 6x squared divided by x squared. That gives me negative 6. Honestly, you can stop here. If you want to go find the remainder, you can. I'll go ahead and do it for you, but it is just an extra step. You do not need to find it. It's more just extra work than anything else. I am totally happy if you stop here. Hopefully I didn't make a mistake in there. But all we really care about right now is the oblique asymptote. The oblique asymptote is going to occur at y equals 2x minus 6.